In this video, I am going to be talking about how we can plot the cosine graph. So hopefully you will have already seen my video on plotting the sine graph. The cosine graph follows a very similar idea. So we're going to be doing virtually the same things that we did when we were plotting the sine graph. So it all comes to this unit circle. This is possibly the most important idea in trigonometry, is the unit circle. So we know that this green length, the height, is sine theta, which is what we've been talking about thus far. But this yellow width here is cos theta, because the hypotenuse is 1. And so that's what we're going to be focusing on now. We're going to be focusing on cos theta. Now we've also saw this picture for the sine graph, which is just the unit circle again, with the same point on the unit circle. But I've also mirrored it in the other 3 quadrants, so we can see how the values repeat themselves. Now we notice that those green lengths are all the same. All 4 of those green lengths are the same, but those 2 yellow lengths are the same, and that is also going to tell us quite a bit about how this works. So if I define this angle as 45 degrees, if I look at this angle, that's the angle going from the starting point, which is always this, well, it's where x is 0, arguably. It's this starting point here. We go around 45 degrees to get to this first red line, and so that's how we know that cos of 45 degrees is 0.7071, or more accurately, root 2 over 2. But if we then go around to the second red line, so we make this full angle here, that's 135 degrees, and so that tells me that this yellow length is our cos of 135 degrees. Now we know that yellow lengths are both the same, but because this is on the other side of the y-axis, this is the negative side of the y-axis, we're going to call this a negative length. So we're going to say that this is negative 0.7071. So it is the same size, it's the same length, it's just negative. We do the same thing for 225 degrees. So this is 225 degrees, taking us from the starting point all the way around to the red line. And we've still got this yellow length here, which is still negative. So cos of 225 degrees is negative 0.7071. And finally, we've got 315 degrees, which is where we've gone all the way around to this last red line. And we've got the same yellow length that we had to start with. So this is the same cos theta that we had to start with. So cos of 315 is 0.7071. Okay, so that's the same idea that we saw with sine. So we shouldn't be surprised by this. We're also going to do what we did with the sine graphs. We're going to start off with the exact values. We're going to start off with the coordinates we already know. So I know that my graph is going to have the coordinate 0, 1. I know my graph is going to have the coordinate 60, 1/2. And I know the other 4. So I can instantly plot that. I can instantly put those points onto the graph. And you can see that this already looks quite different to the sine graph. The sine graph started at 0, 0. This one started at 0, 1. So we are getting a slightly similar, but definitely different shape. Now what we then did was we expanded this idea using our mirror image. So for all of the exact values, we were able to do what we just did. So if I can find, here we go. This is 30 degrees. We can use the same logic to go around to the next red line, which is then 150 degrees. And so cos of 150 degrees is going to be negative 0.866. It's going to be negative root 3 over 2. If we go around to the third red line, that's 210 degrees. So cos of 210 degrees is negative root 3 over 2. And to get to the last red line, we've gone around 330 degrees. And so cos of 330 is root 3 over 2. And we can Add all of those to our graphs, and we get a much fuller picture there. Looking a bit like a bowl, we do often talk about the bowl when we talk about the cosine graph, because that's what it looks like. Now I can add on to this the actual graph, y equals cos of x. And you can see it goes through all of those points, and it does indeed make that bowl shape. Now what you might be thinking is, once again, it clearly knows, the graphing software clearly knows that these lines carry on. They carry on at either end. They carry on going backwards and they carry on going forwards. So here I've got a third plot, which is the same thing, but I'm showing a lot more on the x-axis. And you can see that now actually in this picture, it looks a lot like the sine graph. In this picture, we've got the same sort of pattern as we did when we had the sine graph. In fact, that they are very, very similar pictures. They are both making this wave shape. But in fact, they are not quite the same picture. The cos graph is a translation of the sine graph. So that means that it's the same graph, it's just been moved. And we're going to look a lot more at translations of graphs later on. But for now, I just want you to notice the key differences, because we can see that they're very similar shapes, but you have to know the difference between them. You have to be able to spot when it's a sine graph and when it's a cosine graph. So the first difference, the obvious one that I've already pointed out, is where we cross the y-axis is different. So here we've got the coordinate 0, 0 is where we cross the y-axis, whereas here our y-intercept here is 1 because the coordinate is 0, 1. The next point of interest is over here, because this one is 91 and this one is 90, 0. So when x is 90, we've got 1 for the sine graph and 0 for the cosine graph. And that continues to be a theme. These are the important points that I recommend you learn. You learn all of these ones because they are particularly useful when checking our graphs. And then of course the important point is it starts repeating itself again. So after 360, we then get this bowl reappearing. Just like with the sine graph, we repeated every 360 degrees. We called it 360 degrees periodic. The same thing is true with the cosine graph. We repeat every 360 degrees. It is 360 degrees periodic. Now sometimes you'll be given the full picture, so these are quite full pictures. They're showing quite a bit. Other times you'll just be restricted to the 360 degrees, bearing in mind that that's the thing that keeps repeating itself. This was the original graph based on the circle. So you also need to recognize these pictures, and it's useful to realize that cos is the bowl one and sine is the other one, the wavier one. Right, so the key points in this video. The cosine graph looks like a bowl, but also a wave. So if we look just at a little bit of it, it looks like a bowl, but if we look at it at a greater domain, then it looks more like a wave. The cosine graph goes between -1 and 1 on the y-axis, just like the sine graph did. The cosine graph is 360 degrees periodic, just like the sine graph was. And then finally, the cosine graph is a translation of the sine graph.